All right, let's look at finding the eigenvalues and eigenvectors of the reflection matrix given here in example 202. All right, now I'm telling you that this is a reflection matrix, and so we need to figure out what's the line that's being reflected over. Well, I went ahead and copied the form of a reflection matrix over here, and so if this over here is 1 over 17, that means m squared plus 1 is 17. That means m is either plus or minus 4. And we can figure out which one by looking at this. 2m is equal to 8. So m is 4. So this matrix reflects across y equals 4x. So if we graph out y equals 4x here, do it in red, it's going to look, I don't want a curve, it's going to look kind of like this. It's going to have a pretty steep slope, but this is going to reflect everything across that line. So the things that actually lie on this line don't get changed at all. So the vectors in the span of, remember span just means all the multiples of these guys. The vectors in the span of, what would this be? It'd be 1, 4. Are eigenvectors with eigenvalue equal to 1. And the vectors that are at a 90-degree angle to this, those are going to have a eigenvalue of -1. And those vectors are going to, things that lie on this line would be, well, the slope of that, it's perpendicular to the other one, so the slope is going to be -1/4. So a point that's on there would be, say, 4, -1. And I guess I should say the span of this. All right, so I want to repeat this again. If you're given an n by n matrix and an eigenvalue, the eigenvectors that go with it form a subspace. And so really what I'm doing here is I'm giving the eigenvalue, and this is a basis of the subspace that goes with it as eigenvectors. And ditto up here. So for the eigenvalue 1, this is a basis of the subspace. Now, these two examples were really, they were reflections, so that makes it somewhat easy to figure out where which vectors are going to have, which vectors are going to be not knocked off of their span. Oops. In general, finding the eigenvalues of a general matrix is involves a little more work, and we'll see how to do that in the next video.